Hello friends, in today's video we will focus on the definite integral of the greatest integer function. These kind of problems are very important for few entrance exams like AIEEE, JEE Mains, IIT Entrance, etc. Before starting today's lesson, if you don't know what is greatest integer function, do check my last video, link given in the description box. In this video, I will show you two methods of solving definite integration of greatest integer function. The second method may be the interesting and easiest method. Let's start with the from 1 to 2 greatest integer 3x dx. To solve this problem, we first find out the value of 3x when x equal to 1 and 2. That is, when x equal to 1, 3x equal to 3, and x equal to 2, 3x equal to 6. Therefore, we see that when x varies from 1 to 2, 3x varies from 3 to 6. Now, how many integers are lying between 3 to 6? The integers lying between 3 to 6 are 4 and 5. Let's make a table. Now we have to find out the values of x when 3x equal to 4 and 5. That is, when 3x equal to 4, x equal to 4 by 3. Again when 3x equal to 5, x equal to 5 by 3. We have to break the integral to the point of discontinuity. When 3x varies from 3 to 6, x varies from 1 to 2. The point of discontinuities are 4 by 3, 5 by t, and 2. Therefore, integral 1 to 2 greatest integer of 3x dx equal to integral 1 to 4 by 3 greatest integer of 3x dx plus integral 4 by 3 to 5 by 3 greatest integer 3x dx plus 5 by 3 to 2 greatest integer 3x dx. 1 to 4 by 3, the value of greatest integer 3x is 3. Again, in the range between 4 by 3 to 5 by 3, the value of greatest integer is 4. So now this integration 4 by 3 to 5 by 3 is 4 dx. Similarly, in the range of 5 by 3 to 2, the greatest integer of 3x is 5. This gives 3 into 4 by 3 minus 1, 4 into 5 by 3 minus 4 by 3, plus 5 into 2 minus 5 by 3. Therefore, integral 1 to 2 greatest integer of 3x equal to 4. This is the method 1. Now we are going to method 2. Greatest integer 3x dx. We will solve this problem through graphical method. Now, we are drawing a hypothetical graph of y equal to 3x. No need to draw the appropriate graph. Here, this is the axis. This is x-axis and this is y-axis. First of all, to solve this method, like previous, we have to find out the value of 3x when x equal to 1 and 2. So let's make our table. X and 3x when x equal to 1, 3x is 3. When x equal to 2, 3x is 6. And between 3 and 6, there are two integers, this 4 and 5. And when 3x equal to 4, x is 4 by 3. 3x equal to 5, x is 5 by 3. Let's make a hypothetical graph of y equal to 3x, like this. This is y equal to 3x. Now take some points. 1, this is 4 by 3. This is 5 by 3. This is 2. When x equal to 1, 3x is 3. Say this is 3. When at x equal to 4 by 3, 3x is 4. So this is 4. At x equal to 5 by 3 is 5. At x equal to 2, y is 6. Now we know that The greatest integer function is always discontinuous at integer points, and it is continuous just before the integer points. So when x varies by x moves from 1 to 4 by 3, when x varies from 1 to 4 by 3, 3x varies 3. That's why the value of 3x, sorry, the value of greatest integer of 3x is only 3. This is open circle at 4 by 3. Similarly, from 4 by 3 to 5 by 3, the value of greatest integer of 3x is 4. Open circle at 5 by 3. When x varies from 5 by 3 to 2, the value of greatest integer of 3x is 5. Open circle at 2. Here we can see that there are 3 rectangles are formed. This is rectangle 1, this is rectangle 2, this is rectangle 3. The area of rectangle is length into breadth. For rectangle 1, the area of rectangle 1, the length is 3, this is 3, the length is 3, this is 3. Area of rectangle 2, the length is 4, the area of rectangle 3, the length is 5. So the entire area is area of rectangle 1, area of rectangle 2 plus area of rectangle 3. Now the area of rectangle 1 is 3 into 4 by 3 minus 1. 4 by 3 minus 1 is the breadth of this rectangle 1. The area of rectangle 2 is 4 into 5 by 3 minus 4 by 3. The area of rectangle 3 is 5 into 2 minus 5 by 3. 3 into 1 by 3. 4 into 1 by 3. 5 into 1 by 3. 1 plus 4 by 3 plus 5 by 3 equal to 4. Therefore, integral 1 to 2 greatest integer of 3x dx equal to 4. Now move to the second problem. Integral 0 to 2 greatest integer of x square dx. Method 1. Let y equal to x square. So when x equal to 0, y equal to 0. and x equal to 2, y equal to 4. That is, when x varies from 0 to 2, x square varies from 0 to 4. Let us make a table. Now, check how many integers are lying between 0 to 4. We know that between 0 to 4, there are three integers. They are 1, 2, and 3. Now, we have to find out the value of x when y equal to 0, y equal to 1, y equal to 2, y equal to 3, and y equal to 4. That is, when y equal to 0, x equal to 0. When y equal to 1, x equal to 1. Why 1? Why not minus 1? Because the integration is limit of integration is given from 0 to 2. That is, it is positive. When y equal to 2, x equal to root 2. When y equal to 3, x equal to root 3. When y equal to 4, x equal to 2. We know that the greatest integer function are discontinuous at every integer points. So we break the integration at this point of discontinuity. Here, integral 0 to 2, greatest integer of x squared dx equal to 0 to 1 of greatest integer of x squared dx plus 1 to root 2 greatest integer of x squared dx plus root 2 to root 3 greatest integer of x squared dx plus root 3 to 2 greatest integer of x squared dx. From 0 to 1, but the greatest integer of x square is 0. So 0 to 1, the greatest integer of x square is 0. From 1 to root 2, the greatest integer of x square is 1. From root 2 to root 3, in this interval, the greatest integer of x square is 2. From root 3 to 2, the greatest integer of x square is 3. 0 integral dx value 1 to root 2. Here integral root 2 to root 3. Root 3 to 2. 0 root 2 minus 1 plus 2 root 3 minus root 2 plus 3 2 minus root 3. root 2 minus 1 plus 2 root 3 minus 2 root 2 plus 6 minus 3 root 3 equal to 5 minus root 3 minus root 2. So this is the answer. Now we solve this problem through graphical method. Let y equal to x square. When x equal to 0, y equal to 0. When x equal to 2, y is equal to 4. Now we make a table here. We can see that when x varies from 0 to 2, y varies from 0 to 4. Now, in between 0 and 4, we have three another integers. They are 1, 2, and 3. Now, when y equal to 0, x equal to 0, when y equal to 1, x equal to 1, when y equal to 2, x equal to root 2, y equal to 3, x equal to root 3, y equal to 4, x equal to 4. We now make a graph of y equal to x square. We now draw a hypothetical graph of y equal to x square. No need to draw the appropriate graph. So now this is the x-axis and this is y-axis. This is the curve of y equal to x square. We now plotting. This is 0, 0. When x is 1, y is 1. When x is root 2, y is 2. When x is root 3, y is 3. When x is 2, y is 4. The greatest integer function are always discontinuous at the integer points. This is the hypothetical curve of y equal to x square. The value of greatest integer of x square is 1 when x varies from 1 to root 2. Similarly, the value of greatest integer function is 0 when x varies from 0 to 1. Again, the greatest integer function of x square is 1 when x varies from 1 to root 2, open circle at root 2. When x varies from root 2 to root 3, the value of greatest integer of x square is 2, open circle at 3. 3. When the x varies from root 3 to 2, the value of greatest integer function of x square is 3. Here we can see that 4 rectangles are formed. The rectangles are this, 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 and here, and here. But this is a line. So we have to find out only area of 3 rectangles for finding the value of 0 to 2 greatest integer of x square. If we write this is rectangle number 1, this is rectangle number 2, and rectangle number 3. The of R1 equal to 1 into root 2 minus 1. Area of R2 equal to 2 into root 3 minus root 2, and that of R3 is 3 into 2 minus root 3, and the first, this is 0, this is 0. Therefore, integral of 0 to 2 greatest integer of x square dx equal to 1 into root 2 minus 1 plus 2 into root 3 minus root 2 plus 3 into 2 minus root 3. That is equal to 5 minus root 3 minus root 2. That's all for today.